No? Okay, so who remembers what sine and cosine mean? Okay, so I might as well start with the unit circle. So pretend that's a circle whose radius is 1. So this distance here is 1. And the radius intersects the circle at this point over here, P, which we'll call X and Y. So those are coordinates, X and Y. And so that means this horizontal distance here is X, and this vertical distance here is Y. Everyone, Samantha, problems? Okay. Does everyone follow so far? Yeah. Okay, and so somebody mentioned SOHCAHTOA, Monica. And so let's say that this angle between this radius here and the x-axis is theta. This means that this arc length here is also theta. So the arc length and over here and this angle are the same. And now let's say that you're asked to find the sine of theta. Can anyone tell me how to do that? Oh, this is the right angle. So the opposite to this angle would be y. Y over 1. So it's just y. And cosine theta is x over 1. Okay, so does everyone follow so far? Yes. Fine. It's equal to x. Okay, and how about tangent? Y over x. Yeah, and so tangent is y over x. Okay, and so does this kind of refresh something about sines and cosines? Okay, so the first section in your book is graphing. Don't move. So let's say that the book asks you to graph. For example. No. Nope. Y equals sine x. Nope. Nope. And so over here we have 0, say pi over 4, pi over 2. And so why am I doing this in increments of pi? Can anyone tell me? Yep, radians. And so how many radians are in the full circle? 2 pi? Actually, I shouldn't have done this like this. Okay, so what is the period of a sine function? Can you tell me how often it repeats? No. Are you guys sure? Okay, and so what should I put as on the y-axis? Should I go up to like 100 or like 1,000,000? 1? Now why 1? Yeah, I know, but why? Yeah, because in the unit circle, yeah, the highest x value you can get is 1, and the highest y value you can get is 1. And so the limits on sine x would be anywhere between -1 and 1. Okay, and so I'll draw a unit circle over here, small one. And so we know that, that's really bad. Okay, this is 0, pi over 4, pi over 2. This is just a small one I'm going to keep over here. 4, and this is pi. You guys can probably figure out the rest. Okay, and so if I want to find the sine of 0, how do I use the unit circle to help me? Okay, well for 0, if the angle is 0, the point is over here, right here. And so the sine of 0 would be the y value of that point, which is 0. So that over here. And what about for pi over 4 over here. What is the y value at that point? Okay, it's not 0, it's not 1. Somewhere in between. Okay, it's root 2 over 2, but anyway, I'll just plot a point over here. And how about over here at pi over 2? The y value is... Yeah, the y value is 1, so right here. And how about at 3 pi over 4? Now does this 3 pi over 4 and pi over 4 have the same y value? Yeah, and so I'll put the point here. Then what about pi? What is the y value at pi? 0. Yep, and then same thing in the negative, so this is negative root 2 over 2, negative 1, negative root 2 over 2, 0. So what is the period of this function?
2 pi.
Yeah, 2 pi. Because now it's at the same place again, but notice here the graph crosses 0 here and here, but here it's going in a different direction as here, and so this pi isn't a full period. So 2 pi is the full period. Now what if, as in your homework, you had to graph 2 pi, or sine 2x? Would the graph look the same? That's what I meant, 2 sine x. Yeah, and so the 2 in front of the sine x will change the amplitude of the y value. And so if sine x is between negative 1 and 1, 2 sine x will be between, yeah, and so what should I put here? Yep, and so it's the same looking graph. Because, yeah, I just erased it. So it's the same looking graph, it's just that the amplitude is different. It's not going to have like a squish shape or anything. Yeah. Mm-hmm. Yeah, and so I'll do sine 2x now. So I'll put this back at 1 and 1. But instead of 2 sine x, I'll do sine 2x. Okay, and so if we have sine 2x, what is the value here at 0? What is sine of 2 times 0? Same thing, so 0. But how about at pi over 4? Is it root 2 over 2? Speak up, I can't hear you with this earpiece. Yeah, so what is the sine of pi over 4? Oh, sorry, sine 2x of pi over 4. So, sine 2 of pi over 4. Yeah, and so now sine pi over 2 is 1. So yeah, it's skinnier. And so now this is going to go back here, and here, and here. You can probably draw a better graph, but I just skipped everything. Okay. So now comparing this to our last sine wave, this has gotten a lot skinnier, hasn't it? And so the 2 over here means the period, which used to be 2 pi. So the old period was 2 pi. Now the new period is 2 pi over 2. And so whatever number we have here, it's going to, if it's greater than 1, it's going to decrease the period. And so in this case, it's decreasing it by a factor of 2. Now can anyone tell me what the period would be if instead of sine 2x we had sine 1 over x, or sine half x? Yeah, now the period would be 2 pi divided by 1 half, which is 2 pi times 2, which is 4 pi. Okay. Is there anything else? So we got amplitude, period.
Let's skip to that video.
All right.